hands-free, ultra-wide broadcast system.
Good morning. Can you hear me okay out there? I'm trying to do a sound check here. Okay. All right, great. As you said, I'm Lieutenant Colonel Christian Cook. I'm the MEDEVAC project manager for MEDEVAC mission equipment at MRMC down the road in Fort Detrick. What I want to do today is talk to you about a very, none of this is rocket science. These technologies all exist, but the challenge we have in any innovation, if we see something across portfolio, we've got to put it all together. So we at MRMC have worked with POC3T and NetWarrior, Soldier, and aviation folks to bring you something that automates flight paramedic tasks, captures, stores, and forwards the medical information on evac vehicles, and provides a situational awareness for the gaining medical treatment facility. The reason why this is important, let me tell you, I'm a MEDEVAC pilot for the last 18 years, and I got into program management, really wanted to solve some of our problems we faced out in the field. And one of the things we always find in MEDEVAC missions is we get called out on an urgent MEDEVAC request. You might have one gunshot wound in the chest or something. We get out there and we'll undoubtedly load up more than just that one patient. Might have 2, 3, bilateral amputees or sucking chest wounds or something. How do we let that gaining medical treatment facility know and be prepared to receive those patients? It makes a lot of difference when we come screaming over the fence and land at a hospital pad, and now we have to wait for 10, 20 minutes for them to round up litter teams and get the right triage set up and the specialists called in these sustained operating environments, these combat operations. So what we're going to do is capture that information automatically on board the helicopter without placing any burden on the flight paramedic. That's really, really critical. If he's talking on the radio, if he's having to write stuff down, he's having to do mental gymnastic math in his head while he calculates drugs, he's not treating the patient really. He needs to have his hands on his patients. And an Army Black Hawk can handle up to 6 litter urgent patients. That flight paramedic is going to be absolutely busy, so we need to provide him a system that automates those tasks and doesn't have any additional burden placed upon him. So then he does all that, that information is collected, it's sent over Army Tactical Networks, which we've leveraged with POC3T and the Blue Force Tracker Network. And that gaining medical treatment facility now has situational awareness by call sign, by multiple platform that's out there evacing to them, bringing in patients. So I'll be available after the demonstration, we'll run a demonstration on how we do this. Keep in mind this is a concept, it's growing. None of the material we have made a source selection on at this time. So this is one of those things where we can rapidly take FDA-approved devices, leverage existing things. Like I said, it's not rocket science or new technology, really. We're just creating a system that hasn't been done before to give this system in the hands of an Army combat medic out in the field. With that, I'll let Jay Wang, the product director for MEDHUB, take over and start on the demonstration with our folks. So thanks.
Hi, good morning everybody. My name is Jay Wang. I'm product manager for this system. I'm assisted by retired Sergeant First Class Jeffrey Jones and Sergeant Applin here being our patient. I've also pre-asked for a volunteer. Miss Lauren, you mind taking a seat as a volunteer, and Todd's going to help you out. So as we go over the system, I just want to start with some of the basic concepts that Lieutenant Colonel Cook talked about. Hey Jeff, can you talk about how the hospital receives this information today?
So currently, well, from Vietnam to now, things haven't changed. A flight paramedic or flight medic is in the back of an aircraft making a call to the hospital, just a few minutes out whenever they're inbound with patients, letting them know how many patients, what that patient's status is.
How does that work with all the noise in the back of the helicopter?
So depending on the number of patients, sometimes a crew chief ends up making the call, your pilots make the call, and then they don't have an accurate representation of what's going on with their patients. Or you're just task saturated. And you're saying, hey, I'm 3 minutes out with 3 patients, and that's all you give them.
Now, what's the most tedious part of your job?
Most tedious part. During the mission, I have to document on a piece of tape or a piece of trash, or hopefully just retain it in my head, all the information from all 1 to 6 patients from all 1 to 6 patients in the aircraft. So after the mission, get gas, refill the aircraft, clean everything out, and then at the end of the day, I have to sit down and write all my patient care reports. So if I had 5 missions and 3 patients per mission, at the end of the day, I'm writing 15 patient care reports, either based on some chicken scratch on a piece of paper or straight out of memory.
So it actually sounds like a lot of our day jobs. Administration is one of the biggest obnoxious things that we have to do. So to summarize, what this system does is it's going to be able to capture that data, send it over to the hospital, so we know many, many minutes ahead of time when the helicopter is going to land and the severity of some of those patients are. In addition to that, it's going to take care of the tedious workload that the medic has. And we're going to show you a hands-free, a wire-free, a voice-free system here that's going to do this automatically in the background while he does his stairs. Jeff, could you start us off? While we're doing that, we've also asked Lauren to volunteer. We're going to show you some of the capabilities here that we're going to have. She's putting on her hand right now. One hand, she has a simple vital signs monitor. We're putting it on her hand because we don't want to tape her chest down and do a 1 lead EKG at this moment. So thank you for volunteering. In her other hand, she has a pulse ox that's going to give her heart rate and SpO2. Now that information is automatically being transmitted wirelessly to the board here. And are we showing ambulatory right now? So in the white patient right now, there's a big old A in the center of the screen that says she's ambulatory. Now I'm going to ask Miss Lauren to lie down by flipping her hand over. Palm up. Perfect. And that screen's now going to show she's turned litter, and we're going to have 2 litter patients aboard this MEDEVAC flight. In short, that piece of FDA-approved sensor has an accelerometer on it, just like your phone. It's going to know if you're upright or lying down and how many litter teams we're going to need to send out to that helicopter or ground ambulance to carry you in. If you have 6 patients that are all littered, you're going to need 24 people to bear those litter teams. Would you rather have those 24 people waiting for you when you land, or would you rather wait for them to go get the 24 people? I know which one I would want. So that's what we're actually demonstrating in this equipment. In the kit that we have today, we have a simple vital signs monitor, 1 lead EKG that sits on the heart with accelerometer. We have a SpO2 oxygenation monitor, and we have a blood pressure cuff. So these are some of the basic vitals we can know and up front. Lauren, in this case, is wearing the white sensor kit. Shows up on the white sensor board. If she was, we'll pretend she's a less injured patient. They're going to ask her to go to triage. Sergeant Applin here, let's pretend he's the more injured patient. He's wearing the red sensor kit and shows up all red on the board to the nurses and docs. They may ask him to go straight to the OR. So these are some of the things that we can do with some of the concepts that we can move them quicker into the care that they need. In addition to that, Todd, do you mind turning on the tourniquet? Instead of placing the tourniquet on Lauren, we're going to quickly show you by having a simple sensor that's going to take the date stamp. We're going to have that date information here on when this started, and also send the tourniquet information to the hospital. And as soon as that shows up at the hospital, I'm going to turn it over to Jeff, and he's going to quickly explain to us, or he's going to demonstrate to us, and I might talk, the drug and other treatment capabilities that we can notify just by simply having this information. Now that the tourniquet showed up on the board here, the next stuff we're going to go talk about is weight. How are we doing weight right now in the back of the helicopter? We're guessing your weight. Sir, you look like you're a good 450 pounds. Would you like an overdose of drugs today? So instead of doing that, why don't we get the accurate weight? I'm pretty sure electronic scales have been around for quite a while. So we put an electronic scale on this litter in this case. We're going to get the weight of Sergeant Applin, and for medic screen, sorry, I didn't have the capability to broadcast to another TV, but that's going to show you the weight's already captured, and I've done all the drug calculation for our basic 6 weight-based drugs right now on his screen. Now he just pulls the number of milliliters instead of going through, and on that box we have a piece of tape. He did the math for us there to show going from his weight to the amount of grams back to the amount of milliliters. And if we remember high school chemistry from 20 years ago, then we would actually do a really good job at that. But in other words, why don't we have a calculator do those simple tasks and take away that burden for the medic? In addition to that, now that we now know his weight and know the drugs, we've also captured that information. So at the end of his duty, what he can do is take that tablet, which has no PIA information because we didn't put in the patient's name or social security number. We move it into the hospital, type in his name really quickly and hit the print, and we get a TC3 card. So can you quickly show the tablet removing it as we walk off the plane? And you hit print, you get all 6 of your patients on board that MEDEVAC helicopter, and we are within the same workflows that you do today. What we're trying to show here is that we can make this simple stupid. The medic has never touched this pad during this whole entire thing, is able to know which step he's on and move to that thing and show him the right screen so he can do the right care for the patient. We want to reduce the burden for the medic while giving that information to the hospital. In addition to the basic vital signs and treatments that we described here today, one other vital piece of information is the estimated time of arrival. Based on the Blue Force tracker and the GPS networks, we know where they are, and we know the time of arrival. And that's not sensitive information because this isn't just knowing the distance. It gives you a circle pattern. It's not a specific place in mind. So these are some of the data that we're showing and being able to provide, and the timestamp at the bottom that shows on at 11:10 this morning. So also knowing when the tourniquet is turned on, knows when we can take off the tourniquet and reapply tourniquets, and so we can let the limb breathe. Sometimes those tourniquets have a lot of bandages on them. We forget we placed them there, or the information was lost. So really the key point of capturing this information above the basic vital signs are what are those things that you don't see right off the bat. Whether or not it's a tourniquet, a treatment, blood was given. We can also know how many blood units were given or how many patients need blood, because that's some information that's not actually provided to the hospital. Just because you scream vampire over the radio doesn't mean you have 3 people needing blood or 1 person needing blood. These are the level of detail that we can show in this system. Jeff, was there anything you'd like to talk about that I didn't quite mention?
So right now in the back of the aircraft, your medic's got about 9 to 10 narcotics, and almost all of those narcotics are weight-based medications. And as Jay said before, deciding how much of that narcotic I'm going to give you is based on an eyeball estimate of your weight. And as you know, we all kind of suck at estimating weight of each other. So why do I have such accurate weight-based medications when I can't administer an accurate number? And that's where that litter scale comes in. So we leverage this technology to be able to do all the things that we can't do with our brain at the moment. And imagine you're 6 patients in the aircraft and all 6 patients need your hands at the same time. Those patients eventually need medication. At some point that I have to give that patient medication and be able to do the med math in my head, the eyeball estimation, the drawing of that medication, all at the same time while I'm still continuously thinking and operating on all 6 patients. So what I've tried to do is take some of that task off the medic so we can automatically calculate that medication dose. So the next thing is any medical provider in here knows how many times do you have to log a medication whenever you pull it out. So provider, you can't just go to a closet and grab fentanyl out and then go give it to somebody. You have to log it out of the cabinet, you gotta log it out of the building, and then you gotta administer it to the patient, log it again, and you administer it to the patient. And whatever the waste is, you gotta log that too. So what we're trying to do is create a scale of accountability. So not only do we automatically document that we drew a medication, we automatically document that we administer a medication, but now we can document our inventories as well and keep ourselves honest. And so part of doing that is with this. And then another cool thing about this, give me a little tablet, thank you. In the back of an aircraft, whenever I go to draw up my medication, I'm literally holding the vial in my hand, holding a syringe with a needle, and I'm shaking around trying to make sure I don't stab myself. So we made the device so that we can actually stab it from with the device. Whenever I draw the medication, it automatically signals to the device that ketamine was administered based on that dose. That dose is pulled from the standard medical operating guideline based on MEDEVAC componency's guidelines. So now we can automatically document the whole care based on this. And we can print out a narcotics inventory based on that.
So I really appreciate all of you guys coming and listening to us talk really quickly. We'll take any quick questions. We'll also be at that booth all day long. Yes, ma'am.
Frequency.
So right now we have the medical devices, which are all commercial products. They're using Bluetooth. In addition, our internal sensors, we're also showing ultra-wideband, so it's a broad range of frequencies, very low amplitude. It's the exact reverse of Bluetooth. We're using DoD Tactical Network Beyond Line of Sight Communications, otherwise known as JB's Joint Battle Command Platforms Blue Force Tracker Network. Yeah, satellite frequencies.
The question was, what frequencies are we using on the battlefield for the chopper and the medical devices? That's just for the record.
Are there any other questions? Otherwise, we'll be happy to take questions offline, off the stage also. Yes, ma'am.
You may mention this, but at what point is this program? Is it now being used or is it still in development?
Great question. Right now, we're finalizing the concept. With that, we're moving into engineering, and we're looking for opportunities to do operational assessments. So we're really excited about turning this concept into a final product. With that, then we'll be happy to come off stage and answer any questions directly.